Okay, so to put it in degrees, the first thing we're going to do is we press, just in your normal run mat, we can press Shift menu, Shift and then the menu button, and this will pop up with all the options. You scroll down, the bottom one says angle, and there's 3 options there: degrees, radians, and gradients. And now we're going to learn all about radians and gradients, but for now we want to make sure that says degrees for our right angle trigonometry. So what we're going to do today is we're doing a recap of skills you've hopefully developed in sort of year 9 and 10. So we should remember sine of theta, we've seen that before. Sine of theta is O on H, cos of theta is A on H, tan of theta is O on A. The good thing to remember it, so, ka, toa. Everyone heard that before? Yeah, everyone remember that, fantastic. Sine is O on H, cos is A on H, tan is O on A. Okay, the very first thing we're going to do is label the triangle. So we have a right angled triangle here, and we're going to start by labeling the hypotenuse. The hypotenuse is always the longest side, and it's always opposite the right angle. If this is our right angle, the hypotenuse is the longest side that's not touching the right angle. Okay, you can think of it like that. It doesn't touch the square angle. Next, I like to label the adjacent side. So the hypotenuse is the longest. And the adjacent side, that just means next to, right? It's the side that's next to the angle. So here's the angle that we're given. So the side that's next to it is going to be this one. All right, it's not the hypotenuse. We can also think of it as the side that connects the right angle with the angle. All right, it connects both of those angles together. And then the opposite side is the side that remains, and it is opposite the angle that we are given. Okay, so that's how we label a right angle triangle. Everyone remembering how to do that? Really good. Okay, so let's get straight into solving then. The first thing we have to do when we have a problem like this is to solve, label each side of the triangle. So we'll start with our hypotenuse, which is the longest side. We have our hypotenuse here. This would be our adjacent side because it connects our angle with 90 degrees. And this would be our opposite side. Okay, so we label the triangle. Then we go and we see, all right, we don't have anything at A there, so we're going to disregard A. We want to know what's the trig ratio that involves O and H. O and H. So you can have a look up here, which one has O and H in it? Sine. So what we'll do is we will write out sine theta equals O on H. Okay, that's the trigonometric ratio. Then we will substitute in the information that we have. The angle is 22 degrees. So we're going to put sine 22. The opposite side corresponds with x, and the hypotenuse corresponds with 17. Okay, so we're trying to solve for x, and you can think of what we have here is an equation. We have x divided by 17. The way we get 17 by itself is multiply both sides by 17. So I'm going to show you what's technically happening algebraically. However, all we will write is this. We would just move the 17 up. Okay, so we take that 17 and we're moving it up here. What's technically happening in terms of the algebra is if we multiply both sides by 17, remember with an equation, do anything you want as long as you do it to both sides to maintain balance. On the right-hand side here, we have 17 at the top and the bottom, which will cancel, which leaves us with x. So that's what we're technically doing. Now that's all that we're going to type into our calculator, 17 sine 22, and if we have it set on degrees, it'll pop out with the right answer for us. 6.368. All right, and let's go to 3 significant figures. So that means we write the first 4 numbers, and then we round the 4th number, 8 rounds up. So that takes us to 6.37. And if we're given a unit, we would state it. And in this question, we weren't given a unit. In the next one, we are. Okay, so our answer is 6.37. Right, let's move on to the next one. We're going to label the triangle. We have our hypotenuse here, the longest side, opposite the right angle. We have the adjacent side connecting both the right angle and the unknown angle, the known angle theta. And then we have the opposite side, which is opposite our angle. So we've labelled the triangle there. Now we can see we don't have anything corresponding with h, so we're looking for the trig ratio that involves a and o. A and o. So we'll look along, sine is o and h, cos is a and h, so it has to be tan. Tan theta is o on a. So we'll start with tan. We'll start with the definition of tan. Tan theta is o on top of a. Alright, then we'll substitute in the information that we know. The angle is 46 degrees. The opposite side is 12.1. The adjacent side is x. Okay, so we sub in the information we got. And you can see this form that we have here is a little bit different from the form we had over here. Over on the left problem, we had x at the top. In the right problem, we've got x at the bottom, which means we need to process it a little bit differently. The simplest way to think of what we're doing here is when you have x at the bottom, you just swap it with the tan 46. Okay, we have x equals 12.1 on tan 46. All right, that's going to be your answer. Again, I'll explain the algebra. All right, what we're going to do to both sides is multiply both sides by x and divide both sides by tan 46. Okay, we're multiplying by x and dividing by tan 46. Over here, if I multiply by x and divide by tan 46, we can see we have tan 46 at the top and the bottom here, simplifies to x. And on the right hand side, we have x at the top and the bottom, which simplifies to 12.1 on tan 46. So we'll type that into our calculators. 12.1 divided by tan 46. We've got 11.684. So we'll write the first four figures, 11.68. 8 again rounds, so that takes us to 11.7. And we are given a unit, so we will use the unit this time. Very good. Okay, so there, what we were doing there is solving for unknown sides. And basically, there's three trig ratios that you need to identify which trig ratio. And then, depending on whether the x is at the top or the bottom, that will affect what technique you use. If it's at the bottom, we swap it. If it's at the top, we just multiply both sides by the denominator, don't we? Okay, so let's move on to here. We've got solve for theta. So first thing again we'll do is label the triangle. We have our hypotenuse, our adjacent side and our opposite side. So this time we don't have anything that corresponds with O. So that means we're going to be using the ratio that has A and H. That's going to be cos. Cos theta is A on H. So we'll do that here. Cos of theta is A on H. Let's substitute in the information that we know. We don't know theta. We're trying to solve for theta. So we'll have cos of theta is 15 on top of 29. And then the way we get theta by itself is inverse cos. Now what that means is we go cos minus 1 of 15 on 29. So the way we do that on our calculator is we would press shift and then the cosine button, shift cos, and we need to use brackets, all right? Use brackets or use a fraction, all right? Brackets is safe, you can use both if you want. 15 on 29, and we've got 58.85, which is 58.9 degrees. Very good. Okay, any questions about those? Good, all right, so what we'll do, our textbook doesn't actually